Good morning students, this is Latif sir. In this video I am going to start the chapter 11 of class 12 chemistry. The topic is alcohols, phenols and ether. First I will discuss about alcohols and phenols. Alcohols and phenols. You have already studied in class 11 about different types of functional group, that is carboxylic acid functional group, aldehyde functional group, ketone functional group or hydroxyl group. Okay, so what are alcohols and phenols? Alcohol and phenols are formed, alcohols and phenols are formed when a hydrogen atom from a hydrocarbon. Alcohols and phenols are formed when a hydrogen atom from a hydrocarbon is substituted by a hydroxyl group. Then the product formed is known as alcohol, and the general formula of alcohol is ROH. OH is the alcohol functional group. Okay, so in alcohol the functional group is OH. Now the classification. In alcohol and phenol the functional group is OH. Okay, so compounds in which OH is present as a functional group, they are known as alcohols. Now see classification of alcohols and phenols. Classification of alcohols and phenols. In alcohols the OH group is attached to sp3 hybridized carbon, and these alcohols are classified as primary alcohol, secondary alcohol and tertiary alcohol. So first is primary alcohol, or it is also known as 1 degree alcohol. Secondary is 2 degree or secondary, and tertiary is 3 degree. So alcohol in which the carbon atom containing the OH group, if the carbon atom containing the OH group is directly joined with only one alkyl group, then it is known as primary. If the carbon atom containing OH group is directly attached with two alkyl group, then it is known as secondary. If the carbon atom containing the functional group, that is OH group, is directly joined with three alkyl group or three carbon atom, then it is known as tertiary alcohol or 3 degree alcohol. Again I am repeating, if the OH group present in the alcohol, okay, if the carbon atom containing the OH group, alcohol group, is directly joined with one alkyl group, then it is known as primary. So the general formula of primary alcohol is RCH2OH. RCH2OH, you can see R, then CH2 and OH. And in secondary alcohol or 2 degree alcohol, the carbon atom containing the OH group is directly attached with two alkyl group or two carbon atom. So the general formula of 2 degree alcohol is R2CHOH. R2CHOH. And in tertiary alcohol, the carbon atom containing the OH functional group is directly attached with three alkyl group. So the general formula of tertiary alcohol is R3COH. Okay. So these are three types of alcohol, and alcohol may be classified as based on number of OH group present in the alcohol. Alcohol may be monohydric alcohol, means only one OH group is present. Okay, dihydric alcohol means two OH group is present. If two OH group is present in the alcohol, then it is known as dihydric. Polyhydric means more than two OH group is present in the alcohol. For example, phenol. See, all these three are monohydric alcohol because only one OH group is present. Similarly, phenol is monohydric alcohol. Okay, and catechol, in which two OH group are present. So catechol is a dihydric. Resorcinol is also dihydric alcohol. Quinol is also dihydric alcohols. Okay, so and these are phenol. What is phenol? If OH group is directly attached with benzene ring, then it is known as phenol. Okay, so in phenol the OH group is attached to sp2 hybridized carbon atom. In phenol the OH group is attached to sp2 hybridized carbon atom. And phenol also may be monohydric, dihydric. Okay, here it is different examples are given. Only phenol is monohydric alcohol or monohydric phenol. Catechol is dihydric phenol. These are also one type of alcohol. You can also say these are one type of alcohols because OH group is present, but these are aromatic alcohol. Okay, phenol, catechol, resorcinol, quinol, these are aromatic alcohol. Okay, and next type of alcohol is allylic alcohol. You can see allylic alcohol. Allylic alcohol in which the OH group is attached to the sp2 hybridized carbon but next to the double bonded carbon. For example, example of allylic alcohol, CH2 double bond CH single bond CH2OH. The OH group is directly joined to the carbon atom next to the double bonded carbon. Benzylic carbon alcohol means if the OH group is present is attached with the carbon which is directly joined with the benzene ring, then it is known as benzylic alcohol. That means benzene ring then CH2OH. This is benzylic alcohol. Okay. Now structure of phenol, nomenclature of alcohol and phenol. These are not required. We have already studied in class 11. Okay. Now you have to read about preparation of alcohols and phenol. So first preparation is alkene, from alkene. Okay, so from alkene if you add water or dilute acid, dilute H2SO4 in alkene, then you will get alcohol. Okay, so this is hydration of alkene, addition of water, and addition will follow the Markovnikov rule. Okay, for example, if you add water to prop-1 CH3 double bond CH3 single bond CH double bond CH2 plus water in presence of acid, dilute acid. Dilute acid means water is also present in acid, then you will get CH3 CHOH CH3, and mechanism is given. In first step protonation of double bond is occur, protonation of alkene by attack of H3O plus. Okay, and in first step after protonation a carbocation is formed, and in second step nucleophilic attack by water take place, and in third step deprotonation to form alcohol. Okay, in first step protonation, that is addition of H plus to double bond occur or take place. In second step nucleophilic attack by water to the carbocation, and in third step, in last step, deprotonation to form alcohol. Okay, so acid catalyze hydration of alkene to give alcohol. Next method is hydroboration oxidation, that is B2 addition of B2H6. B2H6 or it is B2H6, that is BH3 whole twice. If you add B2H6 to alkene, then you will get alcohols. And in next step you have to hydrolyze the initially formed product by H2O2 OH minus. Okay, next method is from carbonyl compound. This is the actually reduction method, reduction of carbonyl compound, reduction of aldehyde and ketone. By reduction of aldehyde and ketone you can get alcohol. When aldehyde and ketone reduced by a reducing agent like H2 palladium, the CHO group will be converted into CH2OH group. Okay, CHO group will be converted into CH2OH group. Similarly, ester ketone RCOR, this is a ketone on reduction with a reducing agent NaBH4 or LiAH4, okay, or H2 palladium, this gives secondary alcohol RCHOHCr. So these are preparation of alcohol from carbonyl compound. Okay, similarly acid on reduction with lithium aluminum hydride, the acid group converted into CH2OH group. Carboxylic acid RCOH group is converted into RCH2OH group. Similarly ester on reduction it gives alcohol, two different alcohols. Okay, so these are general method of preparation of alcohols. You have to remember this general method of preparation of alcohol. There are many methods of preparation of alcohols. Next method is from carbonyl compound using Grignard reagent RMGX RMgX is known as Grignard reagent, alkyl magnesium halide, RMgX. When Grignard reagent is added to a carbonyl compound or aldehyde ketone or a ketone, and after hydrolysis in next step, finally you will get an alcohol. Okay, for example, when formaldehyde is treated with RMgX, then you will get RCH2OMgX, and after hydrolysis you will get RCH2OH. Okay, so if formaldehyde reacts with Grignard reagent, then you will get primary alcohol. If acetaldehyde reacts with if other aldehyde reacts with Grignard reagent, then you will get secondary alcohol, and if ketone is react with Grignard reagent, then you will get tertiary alcohols. Okay, so these are general method of preparation of alcohols from carbonyl compounds using Grignard reagent. This is the preparation of alcohol, different type of alcohol, primary, secondary and tertiary, using Grignard reagent. Okay, when formaldehyde reacts with Grignard reagent, HCHO reacts with Grignard reagent, we will get always primary alcohol, RCH2OH. If other aldehyde RCHO reacts with Grignard reagent, R prime MgX, then and after hydrolysis next step I will get, or we will get secondary alcohol always, R2CHOH. Okay, and if ketone reacts with Grignard reagent, then we will get tertiary alcohols after hydrolysis. And next method is hydrolysis of alkyl halide. This is actually substitution reaction. When an alkyl halide treated with aqueous or when treated with aqueous KOH, when alkyl halide RX, alkyl halide is generally represented by RX. When an alkyl halide is treated with aqueous KOH or aqueous NaOH, you will get alcohols. The halogen will be substituted by OH group. Okay. Next is hydrolysis of ether. It is not important. From primary amine, you have to read this one, primary amine. Okay, this is also substitution reaction. When primary amine RNH2, primary amines means RNH2, in primary amine NH2 group is present. So when RNH2 is treated with NaNO2 HCl, that is nitrous acid, NaNO2 HCl, that is nitrous acid, HNO2, the NH2 group will be substituted by OH group. Okay, so this is the preparation, RNH2 treated with nitrous acid. Okay, you will get alcohols. And next it is given by alcoholic fermentation. It is not required. Okay, and now see preparation of phenols. How to prepare aromatic alcohol or phenols. So preparation of phenols. So from first preparation is from haloarenes, from chlorobenzene. When chlorobenzene is treated with sodium hydroxide, okay, when chlorobenzene is heated with sodium hydroxide at 623 Kelvin and 300 atm pressure, the Cl group will be substituted by ONa group. The chlorobenzene will be converted into sodium phenoxide, and after addition of acid in next step, you will get phenol. Okay, phenol. So from chlorobenzene, from halobenzene, you can prepare phenol. You have to treat chlorobenzene with NaOH at 623 Kelvin and at 300 atm pressure, and in next step you have to add acid, dilute acid, and the ONa group will be converted into OH group. Remember the changes. From second method of preparation of phenol is from benzene sulfonic acid. First you have to prepare benzene sulfonic acid from benzene. This is the benzene. You know that when benzene is treated with oleum, oleum means H2S2O7, H2S2O7. Okay, so oleum, when benzene is treated with oleum, that is concentrated H2SO4, and oleum is also known as mixture of concentrated H2SO4 and sulfur trioxide, H2S2O7. When oleum is treated, when benzene is treated with oleum, then you will get benzene sulfonic acid, benzene and SO3H. It is known as benzene sulfonic acid. If SO3H group is present in the benzene ring, then it is known as benzene sulfonic acid. Okay, so when benzene sulfonic acid treated with sodium hydroxide, and in next step H plus, that is acid, is added, then the OH group, SO3H group will be substituted by OH group. Okay, so this is the preparation of phenol from benzene sulfonic acid. First you have to convert the benzene into benzene sulfonic acid, and in next step benzene sulfonic acid is treated with sodium hydroxide in presence of acid, dilute acid in next step H plus. So it is written in single step, in number 1 it is written sodium hydroxide, and in number 2 it is written H plus, that is dilute HCl or dilute H2SO4, and the SO3H group is converted into OH group, that is benzene sulfonic acid is converted into phenol. Okay, next method is method of preparation is from diazonium salt. When aniline is treated, aniline means if NH2 group is present in the benzene ring, then it is known as aniline. Okay, when NH2 group is present in the benzene ring, then it is known as aniline. So when aniline, aromatic amine, is treated with nitrous acid or NaNO2HCl, NaNO2 sodium nitrite and HCl at 0 to 5 degrees Celsius or 273 to 278 Kelvin temperature, the NH2 group of aniline is converted into N2 plus Cl minus, and this compound is known as benzene diazonium chloride, benzene ring, and it is a very important compound in chemistry, benzene diazonium chloride, benzene ring, and above the benzene ring N2 plus Cl minus. Okay, the NH2 group is converted into N2 plus Cl minus, and in next step if benzene diazonium chloride is heated, is warmed with water, the N2 plus and Cl minus will remove and it will be substituted by OH group. So aniline will be finally converted into phenol. Okay, in after 2 steps. So this is the preparation of benzene diazonium salt. First you have to prepare benzene diazonium salt from aniline, and in next step you have to react the benzene diazonium salt with water. And next method of preparation is from cumin, very important reaction from cumin, preparation of phenol from cumin, very important. First you have to know what is the formula of cumin. This is the structure of cumin, that is benzene ring, and above the benzene ring CH3 CH CH3, this group is present. If this group is present in the benzene ring, then it is known as cumin. In first step cumin is treated with air, that is oxygen. The cumin is treated with oxygen or air, it is converted into cumin hydroperoxide. Okay, so see the change. Okay, the CH3 group will be converted like this in this structure, CH3 CH3 and OOH. Okay, this is known as cumin hydroperoxide. And in next step, when cumin hydroperoxide is hydrolyzed with water or with acid, thus this group will remove as acetone, and cumin hydroperoxide will be converted into phenol. So you have to remember the changes. Okay, very important preparation of phenol from cumin. Okay, so now see physical property of phenol and alcohols and phenols. These are not very important, okay, but you have to read to some extent. And only preparation of alcohol and phenols and ether and reaction of alcohols and phenol and ether, these are very important. Okay, so physical property of alcohols given: lower alcohols are colorless liquids, and members from C5 to C11 are oily liquids, and higher members are waxy solids. And the hydroxyl group in alcohols can form hydrogen bonding with water, so alcohols are miscible with water, and the solubility of alcohol decreases with increase in molecular mass of the alcohols, and boiling point of alcohols are higher than expected because of the presence of intermolecular hydrogen bonding in the polar molecules. Okay, and the boiling point decreases, boiling point of alcohols decreases in the order 1 degree to 2 degree to 3 degree as the van der Waals forces of attraction decreases. And now see physical properties of phenols. Phenols, these are also colorless liquid or crystalline solid, but some colored become colored due to slow oxidation with air. And phenol also called carbolic acid. Phenol is also called carbolic acid because of the presence of polar OH group. Phenols form intermolecular hydrogen bonding with other phenols molecules and with water. Okay, so that's why phenol is also soluble in water to some extent. Okay, I have told that physical properties not important. You have to read. Okay, mainly preparation and chemical properties. These are important. All this reaction you have to read, and this concept you have to apply to solve different type of questions. Okay, and next day I will discuss about chemical properties of alcohols and phenols. Thank you, students.